Hello everyone, welcome to JSDC Taiwan and welcome to my talk on web fundamentals for performant web apps. My name is Dhrubojit Pal Chaudhuri and I'm a senior software engineer working for Ascenda. Ascenda is a company that's trying to make loyalty rewarding and easy and accessible for everyone. So feel free to check us out and give us a shout. All right, let's talk about performance. A few months ago, there was this tweet that went viral on this website, which was super fast and super snappy. As an engineer, when we look at this kind of websites, right, we feel very happy and enthusiastic and would like to build something like this ourselves. So we come to our stakeholders, maybe our product owners, maybe our project managers, and tell them, hey, can you allocate some resource and time for me so that I can come and build some fast websites or fast application or improve whatever I have right now? Unfortunately, this conversation doesn't always go very well. And oftentimes we get this pushback from our stakeholders, right? Hey, maybe they have bigger priorities right now. Maybe performance is not as important. It doesn't directly affect revenue. It's too expensive and time consuming. We need to build new features which our users need right now instead. This website is already fast enough. So what can we do when we are faced with such a situation? Well, I think we need to educate our stakeholders on why performance matters. And we need to bring the conversation on their own terms. Firstly, user experience and retention is directly tied to performant web applications. A research done some years back found that if a user has to wait more than 4 seconds, chances are likely that user has already left your website. In fact, more than half of your users will leave your website if your website takes more than 4 seconds to load. Secondly, web performance directly connects to conversion rates as well. A Vodafone case study found that once they reduced their loading time for their largest contentful paint from 8 seconds to 5.7 seconds, they got an increase of 8% sales. That's a direct correlation to profit. Next, we have SEO rankings. Google uses a page speed as a ranking factor. So faster websites will naturally rank higher. They'll get more visibility, and they will also drive more organic traffic. On top of that, it also helps with greater reach. On users who have a slow network or who are on an older device, it's not very easy to access some of our bloated web apps nowadays. So if we can build something that's performant, something that's lightweight, it ensures that we will reach more users and they will have access to our content. Having said that, we need to also figure out what is considered a good performance. Well, thankfully, Google has come up with this statistics, their core web vitals, where they have created this set of performance metrics that measure the user experience of a web page. And according to them, they are the largest contentful paint, the interaction to the next paint, as well as the cumulative layout shift. So what is the largest contentful paint? Well, this measures how quickly the largest visible content element, which can be an image, which can be a block of text, loads on our app. And ideal LCP is less than 2.5 seconds. Okay, so what is interaction to next paint? this measures responsiveness. To provide a good experience, we should strive for a value that's less than 200 milliseconds. Okay, so what do you mean by responsiveness? This refers to how fast our application responds as our user is interacting with it, like as they're clicking buttons, as they're trying to navigate away from one page to the next page, right? And this should be less than 200 milliseconds. Finally, what is this cumulative layout shift? Well, have you ever encountered websites where first a segment of it starts loading, then something else starts loading on top, this has loaded, then this loads, pushes everything below, and as a result, there is this very janky, jarring experience that the user faces. And it can be quite frustrating to see this, right? So this is what we mean by the cumulative layout shift. And a good user experience should strive to have this score of less than 0.1, which means like less than 10% shift in the total content. Well, in summary, our largest contentful pane should be less than 2.5 seconds. Our CLS should be less than 10%. Our interaction to next pane should be less than 200 milliseconds. On top of these 3 core web vitals, I have also added 2 other metrics, which I think are also very important. Excuse me. They are time to first byte, which needs to be less than 200 milliseconds. So time to first byte actually means how fast we can actually serve content from our servers to our client. And then we also want to kind of track our first contentful pane. And as the name suggests, it means how long does it take for the first content of our app to load. And this should ideally be less than 1.8 seconds. Okay, that's a lot of things to keep track of, right? But what is our goal today? We want to make fast, performant web apps. But how do we do all of this with keeping like all of this in mind? Well, let's try to target our low-hanging fruits. And what low-hanging fruits am I talking about today? I'm talking about trying to optimize our critical rendering path, as well as trying to reduce our network payload. Yeah? Okay. So a quick refresher. What is the critical rendering path? On a high level, our browser's rendering engine performs a few steps before they can actually render content onto the screen. First, they need to fetch the HTML and CSS from the servers. Once they retrieve it, they need to parse it, create the document object model, as well as the CSS object model, the DOM and the CSS OM, then merge it together to create the render tree. Then they have to generate the layout on where to place things. And finally, they have to paint the content onto the screen. For us users, it's the easiest thing to optimize for us is to actually optimize this resource fetching part. So let's try to see how we can do that. So one of the things we can do, we can actually give resource hints to our browser rendering engine. Okay, so what are resource hints? Resource hints are basically ways of telling the browser that I will need certain content in advance, so please download them early if you can, so that it's easy for you to parse it without waiting. So some of the resource hints that I would like to highlight are preload and prefetch. What preload does, it will ask the browser to preload critical resources needed for the page to render. Imagine you're parsing from the top to bottom, then suddenly you find something where you need the content. And then you make another network call to the server to fetch it and then render it. What preload will do will instruct the browser that, hey, you're going to need something when you're parsing, can you please download it in advance? So as a result, the browser can render things faster. Then we have prefetch. What prefetch does, it's going to download the resource that might be needed soon as well, but maybe not immediately. It does not have as high of a priority as preload. And we usually use it for things like subsequent navigation that we know the user will perform, right? So you can imagine that, hey, once our web page is loaded, we're going to go into a different part of our app, and the user will click on different links. So you can actually prefetch those parts in advance. Excuse me. All right. Next, we can also use different script attributes to help with resource fetching as well. I'm talking about attributes such as differ. I hope you're already familiar with it. What differ does, it instructs the browser to download certain JavaScript files in parallel while the HTML is being parsed. But it will not actually execute the downloaded JavaScript file. It's going to wait until the HTML has loaded completely and the DOM is completely rendered before it gets executed. We also have the async tag, the async attribute that we can use with our script tags. What async does, it will instruct the browser to, again, download the script in parallel, but this time, once the script gets downloaded, it's not going to wait until the browser finishes rendering anything. It's going to start executing the JavaScript as soon as it gets it. So usually we try to use it when we know that a certain piece of JavaScript doesn't have to depend on any other JavaScript file or any DOM nodes. So let's take a look at it. You have this very basic like a page over here, which is trying to make requests to certain fonts, certain images, as well as certain JavaScript files. And we want to optimize it. It's very simple to do. We can just add certain hints to our browser, as well as like certain attributes to our script tags to optimize it. All right. The next thing I want to talk to you about is preventing layout shift. Whenever we are waiting for something to load from our servers, the client has to wait. We usually present them with a loading screen. More often than not, we use loading spinners. What I'm here to suggest is please use loading skeletons or other placeholders instead. This prevents the user from facing this sudden jerky motion on their app and reduces layout shift. It's pretty easy to do. In React, I have this example set up here where you can see I have like a skeleton loader component. The component kind of like mimics what the actual content is supposed to look like. And I use it as like a fallback for my my suspense prop. So yeah, and this is what the user experience might look like, right? So on the left side, you see on this web app, you see on the left side they're using this loading skeleton, and on the right side the actual content. So once the content actually loads, you don't see this sudden jerky motion. So this is what the experience looks like. It's just there, like the user expects something to appear in that format and it's there, so they don't get frustrated as easily. All right, we're done with optimizing critical rendering path. Now I would like to talk about reducing the network payload. Okay, so the first thing is lazy load components that we don't need in our initial bundle, right? I'm again using React as an example, and it's again pretty simple. So we can import suspense and lazy from React, and we can just use lazily import the components that may not be needed immediately, and then eventually load them once they're required. All right, next I want to talk to you about lazy loading images. This one is a bit tricky. Traditionally, we have been using many different ways of lazy loading images and used maybe quite a significant amount of JavaScript. Maybe we did progressive loading. We used to show dominant colors of an image before we showed them, or maybe we used to, like have different images. Like one we rendered first, which is a low quality image placeholder. Then we replaced it with the high quality image once it was available. Well, what if I told you you don't need to do any of that anymore? Now, with native browser support, we can just have this loading equals to lazy attribute that we can add to our image tags, and this will take care of any kind of lazy loading out of the box. Here's an example of it. As you can see, as the user is scrolling, more and more images are getting loaded. And all we had to do, literally all we had to do, is just add this one attribute. Finally, I want to talk about how to optimize images so that they can be delivered in the best possible manner to our clients. Oftentimes, we may have images from our third-party vendors, or maybe we don't have control over the kind of images that we have to present to our clients. So in this kind of scenarios, we should maybe rely on a CDN to optimize our image before we serve it to our clients. So popular image CDNs like Akamai, Cloudinary, Cloudflare, or IMGIX will support this feature where you can just add a query parameter to the images, and they will give you the image that you need. So for example, for over here, we can see on the cat.jpg, the quality is set to 50, and I want for a height of 500. And doing this, we can go from images on the left to the images on the right. So on the left, you can see that you have an image which is 464 kilobytes in size, and on the right, you can see you have an image which is only around 61 kilobytes in size. This is a reduction of 80%, and quite significant, I would say. Other than this popular CDNs, there are also open source CDNs that you can also try to look into and use. All right, I'm near the end of my talk today, guys, and yeah, before we end, here are some of the key takeaways that I would like you to remember after today. So whenever we want to talk about performance with our stakeholders, we need to show them data. So we want to start the conversation using data and tell them that, hey, this is why performant web apps are important, and this is why you should invest in it. Point number two, easy ways of optimizing the critical rendering path. We can start using resource hints. Similarly, we can lazy load non-immediate components, and we can also lazy load images. Finally, on point number five, we should try to use CDN to optimize images for our application. And finally, point number six, we can have effective loaders like skeletons to mitigate CLS or layout shift. All right. Thank you so much for sticking to the end of the talk. And yeah, thank you so much. You can find the slides here, and feel free to reach out to me and connect to me. And hope you enjoy the rest of the session today. Bye-bye.
Okay. Thank you, Jubajit, for your insightful presentation. Now we are moving to Q&A session. Jubajit, could you say hi to everyone?
Hello, everyone. How are you today?
Hi. Okay, let's see what question we got here. First, would you typically take performance optimization into account during the development phase, or do you prefer only after noticeable issues arise post-launch?
No, it usually depends. Like, we don't want to pre-optimize everything and um, spend too much time before even starting development on it. Personally, I fall onto the latter camp that, hey, we only worry about performance when it becomes a significant blocker, right? But from my talk today, what I wanted to highlight is there are certain thresholds, the Google Core Web Vitals or certain performance metrics. And usually when we're starting a project, usually we tend to fall within those numbers. And as we're building, if we are mindful of our app and the work we're putting in, we can start preventing a lot of the issues that might arise even before the project gets finished. And furthermore, some of the things that I have tried to talk about today are like very, easy fixes or like very small changes that we can start incorporating to everyday work. Um, so those kind of things, I think, and we can start to um, think about like as we're building from the start. I hope that answers your question.
Okay, let's move on to the next question. Do you have any experience with API response cache in front-end side?
Yes, so there are multiple ways of doing caching on the front end, right? Okay, so first of all, our browsers, they end up caching any page we send to them by default. This is even without relying on our servers or CDN. It gets cached locally. And the browser tends to cache them using something called like cache control headers. Or so you can take care, we can kind of like control it based on the time to leave and the e tag that we generate on all of our documents. It's pretty nice. And other than that, there is also like we can also rely on service or workers as well for any kind of like front-end cache. So this is all like caching locally. I'm not sure if that's what you're trying to talk about when you're talking about the front-end cache.
Okay. Due to time restraint, we need to move on to the next session. Okay. Once again, thank you, Jubajit, for your participation.
Thank you, everyone. Hope you have a good session.
Okay. Bye.
Thank you. Bye.